So I'm Alexandra, I work in Red Hat, and today I'd like to share some GDB tricks with you. So the goal of this presentation is to convince you that GDB is actually easy to use, and that with knowing just a few basic commands, it can be incredibly useful. So many people use printf debugging because they think that it's easier and faster. But I'm trying to convince you and to show you that it's actually not true. And in most cases, it's faster to use GDB. The only thing you need is to compile your program with the debugging symbols, passing gflag to GCC, or if it's some bigger project, GDB works better with optimizations disabled. So for doing that, you'll just pass O0 flag to GCC and you can go. So your program is compiled with the debugging symbols and you'll just run it under GDB. That's all. Then you'll just set a breakpoint to the place you would normally place your printf statement. You'll do that by typing B and line number, B10. And you'll type R, and R stands for run. And that's it. GDB stopped at the line 10, and now you can do anything. You don't need printf, you don't need to care about the format specifiers. You'll print your variable. And you printed your variable, and now you need to print some array. You need to print some structure. You need to print something from a different source file. You don't need to recompile your code 10 times. You'll just type P, and GDB will show you. And it will take 3 seconds. So now I'd like to tell you more about setting the breakpoints. This slide is based on the work of my colleague Keith, who has written articles about GDB. So there is more to setting breakpoints than type in B and the line number. You can do a lot of interesting stuff with this. So you can break on functions. If your project contains more source file, you need to specify the source file name and then line number. But you can also break on the labels. You can also break at addresses and the memory, and you can even use offsets. So here you want to break 16 bytes past main. And there is even more to it. If you are interested in that, I highly recommend you to read this article. So imagine you are working with GDB, you set many breakpoints, and you'd like to set that some other time. You want to return to your work later. You can save your breakpoints to some file. And when you want to read from that file, you'll type source and the file name, and all the breakpoints that you have set previously will be set again. When you are setting the breakpoints, you can do conditional breakpoints. Or even you can, using rbreak commands, you can break on a regular expression. But if your condition is complicated, it comes with the performance cost. You can enable and disable the breakpoints. So imagine you placed the breakpoint into some loop, and GDB would hit this breakpoint for 1,000 of times. And you would have to press continue anytime, and you don't want that. So what will you do? You'll disable and then breakpoint number. If you don't know which breakpoint number you need, you'll type info breakpoints. And as you can see here, there is A and B in that table, and Y means that yes, breakpoint is enabled, and no means no, breakpoint is disabled now. So you'll list your breakpoints using info command. You'll find out which number you need, and then you'll disable or enable the number. Another interesting command I wanted to mention is dprintf. Dprintf allows you like printf style print of the variable, but it's a breakpoint. So you'll type dprintf line number, and then you'll type a whole string that you want to get printed once you'll get to this breakpoint number. Here I'm just printing a variable value, but you can print there anything, like my favorite balloon is red. My colleague Kevin wrote a whole series of articles about this. I think it was three articles, and it's very interesting, and I recommend you to read that. Another very useful GDB command is watch. So there is some variable, so you printed some variable, and its value is unexpected, and you don't know what happened. So you can set watch and the variable name. It doesn't have to be variable, it could be array or some other object. You'll set watch, the variable, and when the variable changes its value, GDB will stop, and it will tell you old value of the variable and the new value. Here it's a hardware watch point. So hardware watch point is typically what you want, because it's a hardware feature and it's fast. But sometimes hardware watch points are not possible, and you have to set a software watch point. For example, if you want to watch a register value, you need to, for most registers, it's not most architectures, it's not supported. So it will be software watch points, and because when using software watch points, GDB have to step through each instruction, so it's very slow, but sometimes it's incredibly useful anyway. So for the watch points, you can also use info commands to see what is set currently. You can enable and disable watch points in the same fashion as breakpoints, and you can see here if it's hardware watch point or software watch points. So if GDB is running slow, you can check that. You set some software watch point, and it's the reason why GDB is being so slow. Another useful command is help. So there is some command, you want to use it, but you are not sure about its arguments, for example. You just type help, and GDB will tell you everything about that command. Another interesting thing is, I only found out about this yesterday, but there is something called obscure features. And if you type help obscure, GDB will list obscure commands. Some of them are even experimental. Another interesting command is apropos. So apropos will search for some expression, and it will search for this expression in all the helps. So here I have this example of a break, because you can do a lot of stuff with the breakpoint. You can enable it, you can disable it, you can clear, you can advance. So it will list all the breakpoint related commands to you. The list is very long. Of course, I made it short. I'm mentioning info command again, that you can get a lot of information about a lot of things. As you can see, this list is very long, and it's not a full list. So info breakpoint is what I think you use the most, breakpoints or watch points, but you can also get info about other things like checkpoints, about frames. There is a lot of things that you can get info about. Ptype. So sometimes there is some complicated object, and you don't have to grab for it and open some header file. Here is ptype command for help. You'll just ptype and the object name, and you'll get the object definition. Another very useful thing is x command. X command will show you a value stored at some memory. You can, here, after the backslash, you can specify a format. It can be instruction. As you can see here, it can be, you can specify that you want it hexadecimal, octal, decimal. There are also other formats. If you type help X, you'll get a full list of what you can do. Another very interesting thing is the display command. So sometimes you want a variable value to be printed each time when GDB stops. So GDB stops when there is, when it hits breakpoint or watch point or catch point. So each time GDB will stop, it will print all the variables you want to display. And again, you can use info command to know which variables are set for display, for being displayed. Here, I just want to mention that when you want a backtrace, you'll get the list of frames, and then it's easy to inspect a frame by typing frame and its number. So like frame 2, and you know what happened at frame 2. Few other little tricks. So I guess all of you probably know continue command, but you can specify for how many times should GDB continue to go past some breakpoint. Another interesting thing is tbreak, so you can set only temporary breakpoint. If you want to hit it only once, it's very useful. Also, GDB can call inferior functions, but it's dangerous. So this may cause a segfault. Be careful about that. Also, you can save history of all the commands that you've used to some file and then to see that file. Another good thing is list. You can list any function from your sources, or you can list the source code around the point of execution. Also, I'd like to show you that it's actually easy to do user-defined commands. All you need to do is to specify them in your GDB init file. Or if you only need user-defined command once, you can just type that inside your GDB prompt. So you'll use define command and your command name. So here, as an example, I have show bt command. So for example, you are storing backtrace to some file often. So you'll just create a command for that. So here I want to set login to some file. So I'm setting a file called my backtrace. So, and I want my backtrace to be stored in there. Then I need to set login enabled. And then I'll set conditional breakpoint. And when GDB will stop on that breakpoint, BT will be called, and its output will be stored to this my backtrace file. Then I'll just set login off. And now I can use this command, show BT, and this will be stored to my backtrace file. You can do complicated scripts with this. You can use if or even while. And if you store it in your GDB init file, the comment that you created will be always available for you. For doing even more complicated things, there is Python API. Python API is more robust. With it, you can also define your own commands. You can write frame filters. You can write pretty printers for some complex types. But it's good to know Python for doing that. You can store simple Python scripts even in your GDB init file, or you can add to your GDB init file something like source and your Python script. Here I have an example of really like simple command written in Python API. So first of all, you need to import GDB module. And then I'll create this hello Python class. I'll register it. And then I'll invoke Python code. Here it's just print hello Python. And then now I'll source this Python script. And when I'll type hello Python, hello Python will be returned from GDB. This is very simple, but it's here for just for you to know that it's not that complicated. If you know Python, you'll use it. So I hope that all of you know what Valgrind is. Valgrind is a very useful tool. Valgrind is actually a set of tools, and its default tool is memcheck, and it will help you with memory-related errors. But now you can launch Valgrind from inside GDB. This is a project I worked on implementing with my colleague Mark Vielar. And you need to set up a few commands, and then GDB runs from inside, Valgrind will run from inside GDB. So why would you want to do that? It's because when Valgrind will spot any memory-related issue, for example, it will stop GDB. So Valgrind can send SIG trap signal to GDB, and GDB will stop your program. So here you can see that Valgrind complains about conditional jump that depends on some uninitialized value. So Valgrind sends SIG trap signal to GDB, and GDB stops. And GDB tells you that where it stopped. So it's line 35, and there is if dependent on some flags. And now you can inspect the flags with GDB. Like you'll use like p, like print and flags, and you may realize that there is some garbage there. But not only that, GDB can actually communicate with Valgrind itself. There is something called monitor commands, and it's the way how to send requests. Monitor commands are not specific to Valgrind. It's a way how to communicate with GDB server. But anyway, you can ask Valgrind about things. You can ask Valgrind if this is defined, or you can ask Valgrind if there are already memory leaks at this point, for example. I wrote several articles about how it's useful to use Valgrind and GDB together, and you can read them if you're interested. So here I want to thank all of my colleagues from the debugger team, because they all shared their tips and tricks with me, and also they gave me a lot of feedback when I was sharing my presentations with them, and also all of them wrote some very interested articles about GDB, and you can find them at Red Hat Developer blog. So thank you for your attention.